let's consider an example used for an electrolysis cell. It's common in plating metals out on a particular surface. So let's consider plating gold on a surface. It could be a ring or a piece of jewelry, and we'd make the ring or the piece of jewelry the electrode, and then the gold would plate out on that electrode surface. And we can start with gold dissolved in water. So we have an aqueous solution. So here's gold 3+. We can reduce the gold with 3 electrons to produce gold solid. So this gold solid would plate out on the electrode surface, which is our ring or piece of jewelry. Now, from the current and the time, we can tell exactly how many grams or moles of gold is plated out. So let's do an example with this. So remember, current in amps. So an amp is equal to a coulomb per second. So if we have 10 amps of current, we're running 10 coulombs of charge every second. And if we run that for 30 minutes, we can tell exactly how many moles of electrons that we have run through our reaction. So that 3-to-1 ratio here, for every 3 moles of electrons, we get 1 mole of gold plated out. So we can determine the number of moles of gold. So if we have 10 amps, that's 10 coulombs per second of current, and we run that for 30 minutes. We'll convert 30 minutes to seconds. So I've converted 30 minutes to seconds, so minutes cancels. So I have 10 coulombs per second of current times the time, which is 60 seconds. You'll see that seconds will cancel, and I'll just get the total amount of charge that has been transferred in the reaction. And so this will be coulombs of charge, and Faraday's constant will convert coulombs of charge into individual electrons. So I'm going to erase this so I have room. So now Faraday's constant will have 1 mole of electrons per 96,485 coulombs of charge. So we have a particular number of electrons here. We're going to convert that to moles of electrons. And so now coulombs has canceled, and we've got moles of electrons. And we can use our balanced equation. We'll get 1 mole of gold per 3 moles of electrons from our balanced equation. Now moles of electrons cancels, and we've converted that to moles of gold, and then we can use the atomic mass of gold to convert to grams. So that's 197 grams of gold per mole. So now moles cancels, and this will just give us grams of gold. So in summary, we've taken the current times the time, so that gives me the total charge. And since an electron has an individual charge, that will tell me how many electrons that I have run through the reaction, and I do that through Faraday's constant. And then from the balanced equation, then I can convert the number of electrons to the moles of gold species, and then from moles of gold to grams of gold. So this is kind of an outline of how I'm doing the reaction. Now I plug this into my calculator, and I'll get 12 grams of gold. So at the price of gold today, this is a little over $500 worth of gold plated out on our jewelry.